Thank you, Chairman. Great to be here today, and thank you for organizing this forum. I'm an atmospheric scientist, and today I'll introduce the weather forecast over the Arctic Ocean, especially the Northern Sea route. And my conclusion of my talk is additional atmospheric observations improve weather and the sea ice forecast over the Arctic Ocean and the Northern Sea route. Storms during the Arctic summer is very important phenomena, especially the shipping and navigation. So this system produces the high waves and rapid sea ice advection associated with the strong winds by the storms and cyclones. And we have a Japanese research vessel, and she has been succeeding in observing this kind of cyclones near the marginal ice zone. So our ship is not an icebreaker, but ice strengthened ship. And but she has a very unique observing system. One is the scanning Doppler radar for the precipitation, and the other one is the auto balloon launcher to obtain the atmospheric vertical profiles. So this is the example of the observation. So in 2009, we observed a polar low over the Chukchi Sea, north of Alaska. And the polar low, short-lived and a small-scale low-pressure system. And it could be very difficult to predict by the numerical weather prediction system. However, fisheries and companies of oil and gas are very interested in the precise weather forecast because safety is very important for them. The other case in 2010, this Arctic cyclone is a larger system comparing with the polar low, but this system also provides the very cold air mass from the sea ice, and sea ice advection and new ice formation are very important for the ship navigation. So during this cruise, all research activities except for our meteorological observation were cancelled due to the high waves. And during observation, we launched a lot of radiosondes. Radiosonde is the measurement to obtain the vertical profiles of the atmosphere. And all these data went to the GTS, Global Telecommunication System. So that means the data is used for the numerical weather prediction in real time. So that is our task. For example, this map shows the radiosonde stations used in the ECMWF, European Center of Medium Range Weather Forecast. So you can see that there are lots of upper sounding stations in mid-latitudes. However, over the Arctic Ocean, the station is very few. So that means the Arctic Ocean is very data sparse area. So if we can contribute this kind of system. For example, our ship Mirai also send the data and used in real time in the weather forecast. So why the Arctic radiosonde data important? Because it is possible to improve the weather and the sea ice forecast over the Northern Sea route and the Arctic Ocean. So, and recently, another important thing is the severe winter. Cold winter is very influential for us at mid-latitudes over the Eurasia and the North America. So if we have additional observation from the Arctic Ocean and collaborating with the modeling efforts, better prediction would be available. So as the international framework, so Polar Prediction Project, PPP, is a big project. This project is initiated by the World Meteorological Organization, WMO, in 2013, and its mission is to promote the cooperative international research enabling development of improved weather and environmental prediction services for the polar regions, not only the Arctic but the Antarctic, on time scales from hour to seasonal, very short time scale. And this project is 10-year project. And I'm a member of the PPP steering group member, and we set the special period of the year of polar prediction from mid-2017 to mid-2019. So this period is called YOP, Y-O-P-P, Year of Polar Prediction. And the activity is by coordinating a period of the intensive observing, modeling, and verification. And user engagement and education activities also important point. So last summer, we organized the YOP Summit at WMO headquarters, Geneva, and many researchers and stakeholders gathering there. So Japan has studied a new Arctic project, Arctic Challenge for the Sustainability, so-called ARCS. So ARCS mission is also very similar to the YOP and the PPP. And there are several topics. And topic 1 by myself, predictability study on weather and CS forecast linked with user engagement. And this Japanese project fully covered with the YOP period. So Japan would like to contribute the international framework, Polar Prediction Project. So what we can do right now is to increase the radio zones observations and increase the number of stations using the research vessels and land stations. And such kind of additional observation data, using such kind of data and data assimilation technique, we can evaluate the effect of intensive observations on the prediction and to assess the cost-benefit observing frequency. So polar observation is very expensive, so we have to decide cost-benefit observing frequency and places. And we hopefully propose a future observing network. So the procedure is a little bit complicated, but the essence is we prepare the 2 sets of the reanalysis data set. Which one is the all observation data are included. That is a control reanalysis. And the other one is the same one, but without excluding our additional observations. And we can run the atmospheric forecast models using such kind of atmospheric reanalysis data set as an initial data set. And the difference can be impact of the additional observation. Also, we have predicted wind fields, surface wind fields from these 2 runs, and we can use the ICS couple model by using such surface wind fields as a forcing data. So we can also investigate the predictability of CS over the northern seaboard. So this is example of the our work. This work is a joint research between Japan and Germany. So we focused on the very strong Arctic cyclone in 2012 August. And over the Fram Strait near the Greenland, research vessel Polarstern made a special observation of the radio zones. And that place was the upstream region of the cyclogenesis. So we investigate the impact of the observation. So left panel shows the central pressure, time series of central pressure during a few days. and the black shows the truth of the central pressure. And the thick red line shows the prediction using the data from the polar stream. And the blue one is the just excluding that polar stream data set. So you can see clearly that control simulation prediction using the polar stream data well predicted the central pressure. So we can say that only one station, it is possible and useful to predict such kind of severe weather system. So based on this achievement, we decided to expand the radio zones observing network, collaborating with Germany and Canada. So last 2 years, we made a special observation using our research vessel Mirai. We made a stationary point observation during a few weeks, and we launched a lot of radio zones data, 8 launches per day. And the Inoue, operated by Alfred Wegener Institute, Germany, also contribute to this project, so 6 launches per day. And the Canadian operational stations, Alert and Eureka, also 4 times per day. So all these data sets went to GTS, Global Telecommunication System. So this data truly contribute to the weather forecast in real time. So now it is possible to exclude only this data set, and we can compare to modeling results. So this is the example. So 2013, there is very strong winds induced by the high pressure system. And during a few days, a part of Northern Sea route was closed by sea ice advection induced by the strong winds from the high pressure system. So this is a good case to investigate the impact of the additional observation on the atmospheric forecasts. So this is the difference of the surface wind fields between 2 runs, including the observation and excluding observation. So near the Russian coast, the difference in surface wind exceeded 4 meters per second during a few days. So this value is very large, considering of the ice drift. So we also run the ice ocean couple model using these surface wind fields as the forcing data, and the sea ice concentration and sea ice cover is very different between the 2 runs. So to wrap up, we now know the additional observation is very effective to predict the short time scale severe events. So towards the year of polar prediction, we need lots of collaboration with the operational agencies, meteorological services, as well as the companies, oil and ship, or some fishing ships, because ships also are good observing platform to send the sea level pressure, for example. So if such kind of data are simulated into the numerical model, it is possible to improve the skills of weather forecast. And the coordination of coastal land station also very important, especially Russia. And the impact of atmospheric forecast on sea ice forecast, that is a more applied challenge works. So we have to continue this kind of works. Thank you for your attention.